This pencast is on clearing decimals to solve equations. In order to clear decimals, first what we have to do is figure out which of our terms has the largest number of decimal digits. So if we look at example A, we've got one decimal digit here in this term, one in the second term, and one in the third term. If they all have the same number of decimal digits, then it's very easy, because in order to clear decimals, you just need to move the decimal to the right the same number of places in each term. So in this case, we're going to move the decimal to the right one place in each term. So one's here, and one's here. Now, by moving the decimal point to the right one place, really what we're doing is we're multiplying by 10. And we're multiplying by 10 on each term. And that's one of our rules of algebra. It says that we can multiply both sides of the equation by the same number. So by moving that decimal place to the right one place, we've multiplied each term by 10. So our new equation is 63w minus 15 equals 48. And of course, I am going to change the subtraction to addition of the opposite sign. So we changed minus positive 15 into plus negative 15. Now I want the variable term by itself on the left and the constant term by itself on the right, which means I'm going to have to get rid of this negative 15. So I'll add the opposite, which is positive 15, to both sides. That's going to give me 63w equals, and now here 48 plus 15, that's going to give us 63. So we've got 63w equals 63. Remember, 63w means 63 times w, and the opposite of multiplication is division. So if I want to get rid of this multiplication of 63, I need to divide both sides by 63. 63 divided by 63 is 1, and 1 times w is w. And then 63 divided by 63 is 1. So we get w equals 1. So if we plug w in here, then we would get the same number on both sides of the equation. And remember, you should always be checking your work. For the second example, example B, the one thing to remember is that since we have these parentheses here, this whole first part right there is one term. So we've got one term there, one term here, and one term here. So we still have three terms. When I look at the decimal digits, I've got one decimal digit here and one decimal digit here. So I'm going to have to move the decimal one place to the right to get rid of those decimals. But if I look at the 2, there is no decimal there. But I do have to remember that the same thing is 2 point. So I can actually give it one decimal digit if I want to. Now I'm going to move each of these decimals one place to the right. And that's going to give me 4 times n plus 10 plus 6n equals 20. Now distribute the 4 to the n and the 10. That's going to give me 4n plus 40 plus 6n equals 20. Rearrange our terms so that the like terms are next to one another. So the 4n and the 6n. So 4n plus 6n plus 40 equals 20. Now combine those terms since they're on the same side of the equation. That's going to give me 10n plus 40 equals 20. At this point, I want to get rid of the 40. So I can either subtract 40 or I can add negative 40. In this case, I may want to add the opposite. So add negative 40. That cancels, and I have 10n equals 20 plus negative 40 is negative 20. Finally, 10n means 10 times n, so I need to use the opposite operation, which is division. So I divide by 10. 10 divided by 10 is 1, so I have 1n, or n, equals 20 divided by 10, which is negative 2. Or negative 20 divided by 10 is negative 2. And we're done. In example C, this one is different because we have decimals and we have fractions. So the first thing I'm going to do is the same. I'm going to look at my terms and figure out which one has the largest number of decimal digits. And that's right here, because we have 2 decimal digits, which puts it in the hundredths place. So to get rid of those decimal digits, we'd have to move the decimal point 2 places to the right, which is the same thing as multiplying by 100. So what I'm going to do is I'm actually going to multiply each of these 4 terms by 100. So we've got 100 times 0.5x plus 100 times 0.25 equals 100 times 1/3 x plus 100 times 5/4. Well, multiplying a decimal by 100 means move the decimal point 2 places to the right. But I have this empty spot, so I'm going to have to put a 0 in there. So that's going to come out to be 50x plus, once again, 100 times 0.25 means move the decimal 2 places to the right, which gives me 25. Now, 100 times x, when I multiply fractions, I want that whole number to look like a fraction, so I give it a denominator of 1. 103 have no common factors, so I can't cross reduce, so I'm going to have to multiply straight across. That's going to give me 100 over 3x plus my last term. 4 does go into 125 times, so 4 goes into 4 once. 4 goes into 125 times. So we've got here 25 times 5 is 125. 1 times 1 is 1. So 125 over 1 is just 125. Now I got rid of the decimals in that step, but I still have a denominator of 3. But there's no other fractions. So what I need to do is go through and actually multiply each of these terms by 3. So I would do 3 times 50x, 3 times 25, and then since this is a fraction, I'd use 3 over 1 times 100 over 3x, and then 3 times 125. So 3 times 50x gives me 75x, plus 3 times 25 gives me 75. Whoops, 3 times 50 is 150. Sorry about that. So 3 times 50x is 150x. 3 times 25 is 75. Here the 3's are going to cross cancel. So we have 100 over 1, which is 100x, plus, and then 3 times 25 will give me 375. I don't have any like terms to combine, so I'm going to go right to moving the variable term to the left, which means I have to get rid of the 100x. So I subtract 100x from both sides. That's going to give me 50x plus 75 equals, those cancel, 375. Get the constant term on the right, which means I have to get rid of the 75, so subtract 75 from both sides. That cancels, so I've got 50x equals 300, and then divide by 50 on both sides. Now remember, if you have common zeros at the back, you can cancel those, so really it's 30 divided by 5, which is 6.